Learning Objective 1.2, the student is able to select and apply mathematical routines to mass data to identify or infer the composition of pure substances and/or mixtures. Yay, science! Some important definitions to know are the empirical formula, the molecular formula, and percent composition. The empirical formula gives you the simplest whole number ratio of atoms in a compound. The molecular formula gives the number of atoms of each of the elements present in one molecule of a specific compound. Percent composition is the percentage by mass of each element in a compound.
The formula for percent composition is the total mass of elements present over molecular mass times 100.
The science practices I used are 1, 2, and 5. Science Practice 1. The student can use representations and models to communicate scientific phenomena and solve scientific problems. Science Practice 2. The student can use mathematics appropriately. Science Practice 5. The student can perform data analysis and evaluation of evidence. Yay, science! Caffeine has the following percent composition.
Carbon 49.98%, hydrogen 5.19%, oxygen 16.48%, and nitrogen 28.85%. Its molecular weight is 194.19 grams per mole. What is its molecular formula? Using Science Practice 1, the M&Ms represent the ratio of the elements that make up caffeine.
Blue is carbon, yellow is hydrogen, green is oxygen, and orange is nitrogen. Yay, science!
Using Science Practice 2, I can find the empirical formula. First, you change the percentages of each element into grams, and then you multiply by moles over the atomic mass of each element. Then you divide by the smallest amount of moles to find the ratio of the elements.
From that, we know the empirical formula is C4H5N2O. Next, to find the empirical formula weight, I multiplied the subscript of each element by the corresponding atomic mass of the element.
Now, since we know the empirical formula weight is 97.1 grams per mole, we can find the scale factor.
I divided the molecular weight by the empirical formula weight to get a scale factor of 2. Now, since we know the scale factor, we can find the molecular formula. You multiply the empirical formula by 2 to get C8H10N4O2. Yay, science! This is a 3D model of caffeine in its molecular structure. You can see that caffeine has a double ring structure. Caffeine is made up of 8 carbon atoms, 10 hydrogen atoms, 4 nitrogen atoms, and 2 oxygen atoms. The scientific name for caffeine is 1,3,7-trimethylpurine 2,6-dione. Thanks for watching, and I hope you learned something new!